Greetings to all in Dr. Abha Chemistry Pathshala. I hope you enjoyed my series on Unit 12 and Unit 13. That is Markovnikov rule, and it has got everything to do with the chemical properties of alkenes and alkynes. Symmetrical alkenes क्या है और unsymmetrical alkenes क्या है? देखिए, symmetrical alkene वो alkene होता है जिसमें डबल बॉन्ड, जो alkene का डबल बॉन्ड है उसके आसपास का जो एनवायरनमेंट है वो बिल्कुल आइडेंटिकल होना चाहिए, जैसे कि ब्यूटूइन। और ये सारे के सारे आप एग्जाम्पल्स देखिए, ये सिमेट्रिकल alkene है और आप देखिए डबल बॉन्ड के आसपास जितने भी alkyl ग्रुप्स हैं वो दोनों तरफ आइडेंटिकल हैं। Unsymmetrical alkenes, butene is an unsymmetrical alkene, propene is an unsymmetrical alkene, pentene is an unsymmetrical alkene। इसमें क्या होगा, डबल बॉन्ड के दोनों तरफ के जो एनवायरनमेंट है वो डिफरेंट होते हैं। सो आई होप यू आर क्लियर विद व्हाट इज एन अनसिमेट्रिकल alkene। अब हम आते हैं जो रिएजेंट अटैक करेगा। ऑफ कोर्स अटैक पहला जो स्टेप होगा वो इलेक्ट्रोफाइल का होगा, बट लेटर ऑन न्यूक्लियोफाइल ऑल्सो गेट्स एडेड। सो बेसिकली वी आर शोइंग द एडिशन रिएक्शन। सो जो एडेंडम होना चाहिए, जो अटैकिंग रिएजेंट होना चाहिए, वो भी अनसिमेट्रिकल होना चाहिए। लेट्स लुक एट फ्यू ऑफ द सिमेट्रिकल अटैकिंग रिएजेंट। H2 हो गया, Cl2 हो गया, Br2 हो गया। बोथ द न्यूक्लियाई आर आइडेंटिकल। तो ये होमोन्यूक्लियर स्पीशीज़ हैं, इनमें अटैकिंग रिएजेंट जो है उसे हम सिमेट्रिकल कहते हैं। तो इसमें अगर आपको ये दिखता है तो मार्कोनिकॉव रूल नहीं लगेगा। सो मार्कोनिकॉव रूल को लगने के लिए हमें अनसिमेट्रिकल रिएजेंट चाहिए। HCl, HBr, HOH, वाटर, H2O, H2SO4, all these are unsymmetrical alkenes. So now coming back to Markovnikov rules, attacking reagent का electronegative part उस कार्बन पे लगेगा जिसके पास कम हाइड्रोजन है। तो एक बार हमें इसकी मैकेनिज्म का जानना बहुत ज़रूरी है, ऐसा क्यों हो रहा है, क्या ये रूल्स सभी अनसिमेट्रिकल रिएजेंट्स के लिए एप्लीकेबल है। सो आई विल बी नीडिंग अ स्क्रीन टू राइट, सो लेट्स क्विकली मूव ऑन टू द स्क्रीन। So the rule says the addition of unsymmetrical reagents, right? So the reagents should have different electronegativity to the unsymmetrical alkenes. That is the alkenes which have double bond having different environment that occurs in such a way that negative part of the reagent, it goes to the carbon which has lesser number of hydrogen atom. So here across the double bond we have different alkyl groups. So this is an unsymmetrical alkene. On such an alkene, if we add HCl, the more electronegative part, that is the Cl, will get added to the carbon which has lesser number of hydrogen, right? So if we just want to show the addition, so if we just want to show the Markovnikov addition, the answer will be CH3, CH, and we will have a Cl here, and then we will have a CH3 here. So we get 2-chloropropane, right? It's a very simple mechanism. We are aware of the fact that 3-degree carbocation is more stable than 2-degree carbocation, which is more stable than 1-degree carbocation. It can be explained via plus psi effect or via hyperconjugation. You can go through the video of hyperconjugation in case you are not very sure about it. So we take the same alkene. I take propene, right? This is my first carbon and this is my second carbon, and I add HCl to it. I add HCl to it. So there are two places where it can get added, right? The first step definitely will be the attack of electrophile. So H will get added first. Electrophile gets added first, and it is going to be the rate determining step, and it is going to be the slow step. Now H has got two places. So let us assume H gets added at the first carbon, right? So we have CH3, CH, CH3 and a carbocation here, and this is a 2-degree carbocation. Then in the next step, which is a fast step, Cl minus, that is a nucleophile, gets added at the carbocation. In the fast step, Br gets added to the carbocation to give you 2-bromopropane. Which is the major product. There is one more possibility. If H plus gets added at C2, again the slow step, if it gets added to C2, we get CH3, CH2, CH2, a carbocation which is a primary carbocation, 1 degree carbocation. In the second step, this is less stable, this is definitely less stable than the carbocation formed here. Look at this carbocation and look at this carbocation, right? So now in the next step, Br minus gets added, this is the fast step, and you get you get 1-chloropropane. I'm sorry, this will be, I'm so sorry, this is going to be Cl, and this is, so 2-chloropropane will be the major product, 1-chloropropane will be the minor product. Here we will show rearrangement of carbocation. During Markovnikov addition. Let's take case 1. We take 3-methylbutanene. The first step will be, so H plus gets added to the carbon, terminal carbon, so as to give you more stable carbocation. So first carbon पे आपका hydrogen add हो जाएगा, and what you get towards the end of the addition is, and this is a 2 degree carbocation. This is a 2 degree carbocation. The next step is going to be nucleophile addition, and this is going to be a fast step. See, so there will be two cases. Either it gets added here itself, and to give us a minor product. Now why it is a minor product? Because we are getting a 2 degree carbocation. There is one more possibility. If in the same carbocation we show this proton ka shift, if we show, let me write it again differently. I have just written that differently so as to show if this goes to this carbon, right? So what you will get is, you will get a carbocation here, CH2 and CH3, and this is going to be a 3 degree carbocation. Definitely it is going to be more stable, and next step is going to be attack of Cl minus, which is a fast step, right? And then you get a different product. So here you are getting 2-chloro, 2-methyl butane, whereas here you get 2-chloro, 3-methyl butane. So this is one of the case of hydride shift to give us more stable carbocation. So we can take one more example. So we take one more case of Markovnikov addition. Here we will take a shift of alkyl group. So we start with we have 3,3 dimethyl butene. We show the addition of HCl. The first step is going to be addition of H plus, which is a slow step. So definitely it will get added at the terminal carbon so that we get a 2-degree carbocation, so that we get a 2-degree carbocation. So the product is going to be CH3, C, CH3, CH3, CH and CH3, and this is a carbocation. This is a 2-degree carbocation. There are two possibilities. The first possibility is if the nucleophile, the Cl minus, gets added at the 2-degree, right, giving us, so this is the first possibility, we get 2,2 dimethyl, and at the third position we have chloro. So this is 3-chloro 2,2 dimethyl butane. This is going to be minor product. Why is it going to be a minor product? Because it is on the secondary carbocation. Next, just see, what if this alkyl shifts here? If this alkyl shifts here, you have, here you get a 3-degree carbocation, and the last step is going to be attack of chloride, which is going to be fast step, and you get, so what you get is 2-chloro 2,3 dimethyl butane. This is your major product. So that was all about Markovnikov rule. That was all about Markovnikov rule. Markovnikov rule एक बहुत important rule है आपकी जो organic chemistry को govern करता है. Till we meet in the next video, I take care of yourselves. God bless.